Okay, folks, today we'll talk about geoprocessing, this very important concept for doing GIS work. But before I do that, I wanted to bring this to your attention. If you haven't found this as you were downloading the software, make sure that you are aware of this resource from ESRI. It's a good resource to have. It's where I've gotten some of my more basic data files and things like that to get very reliable. They're not perfect, but they're kind of consistently good enough for a lot of projects that we do. When you get into higher end, say, cartography work, ESRI isn't necessarily the first place you want to go to for data, but this works for everything we're doing in here. So in this My ESRI page where you've downloaded stuff and checked your different licenses and all that, down here in media and this download ISO files or ISO files, you scroll down here, you'll see, and I think mine probably has all this because I've downloaded these in the past. I don't know if you'll see all of these different versions of ArcGIS or not. But once you go past this, down here you'll see this data and maps for ArcGIS. And I have a bunch of them from the past, from some of these previous versions. But you can download, so right here, this data maps for ArcGIS 2017 for version 10.6, which is what we're using right now. It's roughly 4 gigabytes, about the size of a DVD. So it's a big file. It can take a while to download, depending on how fast your speeds are, but it's a very useful thing to do, and I recommend just going and doing it and looking at some of the files, and it gives you some material to play with when you start working on your final project for this course, which I'll be posting really quick here and give you a sense of what I want you to do. Instead of a final exam, you're going to be doing a final project for the course, and these data files can be very useful for that. So when you download it, you'll get something like this right here. You can see the little kind of disk image there, and what this is, it's a this ISO file. It treats it like a CD or DVD or Blu-ray or whatever that you put into the computer. So this is very easy to burn to an actual Blu-ray or DVD rather, if you want to do that. It's too big for just a normal CD, so you could do that to save room on your computer and just have this resource. But when you download it, if I double click on it, here you'll see Europe, USA, World. Those are the main different data sets. And of course, with the US and Western Europe, really, we're going to have more comprehensive and more detailed data for some of these nations, and for the world, it can be kind of spotty depending on what region you're working in. And clearly, if you're doing a project in some foreign locale, while ESRI might not be the best resource, a lot of countries around the world have GIS data available in some capacity, like official stuff that can work. So there are other places to look, but this will give you a very good underlying base map. And with this, you're not going to be able to see much in here until you actually pull it into ArcGIS. Like if I go in here to census, this .gdb that you see here, that's all geodatabase stuff. So it won't make any sense if I click in here. It'll be these mystery files. But again, going through ArcMap, pulling it through ArcCatalog, you'll see the actual files themselves. It'll make sense. But I would recommend, if you're able to, download the stuff, play with it. There's a lot of good stuff in there. All right, now let's close this and get to what I really want to talk about here today. Let this load up. And so what I want to talk about primarily today is this idea of geoprocessing, which is a very important component for GIS. And it's, I mentioned before with attribute tables when we were talking about actually messing around with tables having information connected to the shapes. That's a big part of GIS. Geoprocessing is another equally important component where we can take multiple feature classes. We get these different layers that we bring in, and we can compare them, we can contrast them, we can do different things to analyze these different layers and see how they are connected to one another. So we can really ask these spatial questions, right? Where is something in relation to something else? What is near this specific thing here? What's the best location to place this thing, and so on. So I'm going to introduce you to some of the main tools that we have. I'm going to show you how to access these things, and then later on I'll also be giving you a handful of exercises where you'll start to do this. You'll start to bring in layers and do this geoprocessing work to them and get new layers that are produced. You'll be able to answer a lot of spatial questions. So this is the cool stuff that we're getting into. So when doing geoprocessing, a lot of the stuff you're going to be working with is embedded in ArcToolbox. And in fact, let me pull up ArcMap. Mine's loading. Hold on. And so what I'll show you is ArcToolbox itself, but there are a few different ways to get at these tools. Like, unfortunately, we have so many tools that it can be kind of frustrating to figure out where that one tool is to try to track it down. So we have them; they're all in ArcToolbox. You can find them manually, but we can also search. There's an index. There's a whole host of things we can use. So if I open up ArcToolbox, I think I showed this to you like early on with one of the first videos, and it's really tired, so just bear with me. It's one of the finer bits of ArcMap and ArcGIS is how slow it can be. So in here, we have all of these different tools, and so I open it up like Clip. We'll be talking about that one. If I just know where it is, I can go right to it. It's no big deal. Another thing, you have this Geoprocessing tab. This is a relatively new addition. I think I clicked on that one. There we go. They have these six primary ones right here, just the ones that you're going to more often going to need to use. Right? There are plenty of other ones that are very useful, but these are some pretty general ones, so they just put them right there as kind of a quick access thing, right? So if I know I need to do one of these, I can just go there, click on it there. Search for tools is another thing, and it pulls this up, and I can just type in, like if I know it's Clip is the name of it, that'll work. And this gets a little funky because if you don't remember the exact name, you might have a hard time. But still, type what you expect it would be called or what you think it should do, and sometimes you can find it. And we have a few different options. Typically, if you don't know, like coverage versus some past stuff, you don't need to worry about. If there's stuff that doesn't seem that familiar to you, don't worry about it. Since you would use this tool for analysis purposes, you could select on that, and it takes you here to this one. So like this coverage thing, again, don't worry about it. But this one, if I click on it here, it's going to open up the actual tool itself. Just like if I clicked on it here, it would open it up, and it gives you these different options and things you can use. There are a few different ways to get at it. Just keep that in mind because that can be a pain to try to track this stuff down. And when in doubt, you can also Google, and chances are you're going to find some resource out on the web. Now, another thing to do is when you open this up, if it looks exactly like mine does, click on Show Help, and it will give you this little sidebar that kind of explains what it is this thing is going to do. If I really open it up here, you can see the full thing. So this, I always have this open. I think it's wonderful to have this open constantly. It kind of defaults to not opening it up when you first load the software, but I think it's really useful to have, if for nothing else, you have these cartoons that can help you make sense of what this tool is going to do. So like this with clip, and we'll talk about it in a bit, but it's showing how you put in this specific input. You have some kind of data that are going into it, and then you have your clip feature, which is like a cookie cutter, and it's going to properly overlay these two things. So they're also connected to spatial coordinates and all that. But when you overlay and put these things over one another, it will use the clip feature to cut out only the relevant information for that input data. So it cuts out this circle shape, gets rid of the other stuff, and I'll get into how that's useful in a bit. But that's how we find the tools, and as I said, make sure that you have this help thing open. I've been using this stuff for years now, and I use this constantly because it just helps me make sure I know what it is I'm doing. I don't make silly mistakes. And with things like union and intersect, two tools I'll talk about, sometimes they're so similar, yet at the same time still very different. You can easily make a mistake there. So I just use that as a kind of a safety feature. All right, so this is where our tools are. Shrink that down. And so, let me go back here. So search, there's an indexing function, which is kind of like the search thing, but it's a more specific deal. There's the help option. That's what I was talking about with the tool itself. So make sure those things are set and up and running before you start working with this stuff. Now, of the tools themselves, I'm just going to point out a few key ones that I think are useful. And they're going to be things that we use in this class, you'll use for your final project. You'll go on. These are the kinds of things, if you go into work in GIS, this is what you use quite a bit. So the first one, clip, which is the one I just showed you. So it's that cookie cutter idea. And it's really useful. Think about, we have US data set. So I have the example here, National Rivers Layer. So every major river in the United States, that can be a very useful data set. But if I'm only working in a specific state, like let's say the state of Michigan, I don't necessarily want to have all of this other river data that's taking valuable, processing and graphics card resources and all that from my computer. I want to get rid of that stuff that doesn't matter at all. So if I'm only working in Michigan, well, then that's what I'll do. I'll take in this national data set, run the clip tool, and I'll clip it so it's only the rivers that are within that specific state, right? And we'll see some of that. We'll have a lot of experience with that in this class. Erase is a tool that's kind of a similar concept, that we're extracting things, but it works in the reverse, where we're actually removing something from the inside that cookie cutter, right? So whereas with this input, put the clip feature over, it's only keeping the stuff right there in this clip feature. Erase is doing the opposite, where it's erasing whatever's within this square shape here, so it actually removes material. And so this can be useful for if you're trying to eliminate data that just don't fit your search criteria, or something like that. And we'll see. I'll have some examples as we do some stuff. It's a very useful tool, but I think it kind of helps if you're actually doing it, using it for something when it is relevant. That helps show why you'd want to use it. And unfortunately, it's only available with the advanced or ArcInfo license. So if you've done that ArcGIS for personal use or whatever, you should have it. But often if you're working for a company, some of our computers in our GIS lab at AVC have this, where they're that basic or ArcView level. They don't have access to this. So it can be quite frustrating. But all of you who are using this on your computers, if you got that personal use license, you should have that, I believe. And we'll figure that out together as we work through some different exercises. Okay, union and intersect are these what we call combination tools, where we're bringing things together. We're not extracting stuff, but we're trying to combine multiple feature classes. And I have here, to point this out on the other ones, this is where it's located in ArcToolbox. So it's the analysis tool set that you first see. You look for overlay and then find union. So just so you can get a sense of where these things are. And so with union, we would overlay two different layers here, feature classes. So we have this circle and these two rectangle pieces that are stuck together. And a union is going to put these together, and it's going to keep everything like we see here. So it's not getting rid of any extraneous material at all. It's if they touch, it'll keep it. If they don't touch, it'll keep it. And so this can be useful if you want to say you're going to overlay. You could have soils and vegetation types. Put those two things together, and you get a sense of what vegetation and what soils are going together. If you want to use that for some kind of later analysis, say that could be a way to do it. And we'll play with some of these as well. But you're taking multiple data sets and you're bringing them together to combine that information. All right? Whereas intersect is where you're doing the same thing. You're overlaying these two features, but it's only where they touch. So this stuff up here, this little half circle, get removed, and it's only the intersecting features, right? And so that's good if we're looking for a specific thing. Say we're looking for a specific vegetation type and soil type for some kind of, ecological analysis or whatever it might be. Maybe I only care about one specific combination. That's where the intersect function would come in handy, right? I get rid of that stuff I don't actually care about. Now, these are actually two separate tools here. And again, adding stuff together, combining things. You have append and you have merge. And really the main difference is merge is where you take two files and you're going to stitch them together, but you're going to make a new file as a result. So you don't actually change the original files at all. And I should say with these other ones like clip and erase and union and all of that, it's that same idea where you don't actually change the original files, you're making something new. So you preserve your original data and produce something brand new that you can manipulate, you can delete later, whatever, but you've maintained that original source data. Append is where you do change that original bit of source data. So that's really the only difference there, at least as far as I know. There might be some other underlying difference, but really what you're doing is you're just trying to stick multiple files together. So you have one continuous larger file. And there are two examples here where you have these kind of overlaying things as well as things that are right next to one another. My example here, if you have multiple counties in California you're working in, and you have different layers for the roads or rivers or geology or whatever it might be, it's very tedious to work with a separate thing for Kern County, a separate one for LA County, and a separate one for San Bernardino County. So by merging those three separate ones together, you only have one data file now that you have to do whatever work to, symbolize a certain way, label a certain way, do more geoprocessing to, whatever. So that's the usefulness of merge. Dissolve is a simplification tool, meaning that we're taking something that's more complex, like you see here, and we dissolve a certain feature, so it gets rid of those interior lines, and so it just leaves a much more simpler concept. Okay? So you're simplifying this group of polygons based on some common field in the attribute table. let's say if you had all of the counties, the different counties in the United States, that would be useful in some cases, but can also be big and unwieldy. If it also had a states field in there, you could dissolve it based on states, and then it would take, say, every California county. If it's in California, it would dissolve those county boundaries and just leave the boundary for California, right? And same thing for Nevada and Arizona and so on, right? So it's a way to simplify things, which again, with all of these, it's not always useful to do that, but sometimes it is. And ArcGIS has the ability to do that. And a buffer is a very useful tool, although kind of a overly simplified tool at the same time. And a buffer tool is looking at a certain proximity around a feature. Okay, so you've got your input coverage here, these two little polygons that exist. You run your buffer tool and it draws this thing outside of that is set distance, right? So you could say like a 1 mile buffer around here would measure out 1 mile from the actual feature and then draw that line around it. You can see where these overlap. You can dissolve it, which is what this one did. So you don't have two separate buffers. It just kind of simplifies it, blurs those together. So you get a sense that, in this green area, that's within 1 mile of these yellow polygons right here. Okay? And so this is useful if you say, have things like something cannot be within so many miles of a school or a playground or whatever, right? You go with a lot of legal things. You maintain a certain distance between, X and Y. This is a very easy way to draw that. So if, it needs to be 3 miles away from a school, you get a schools layer, draw a buffer 3 miles around each school, and you get a sense of what area must be free of, whatever it is that you're dealing with. Now, the problem is, with this, it is very simple. It's good for like legal, almost arbitrary boundaries, if you want to think of it that way. If you're dealing with something like, an oil spill or a chemical, spill or something like that, this isn't an accurate representation, right? If you say you had some spill that contaminated areas, 5 miles around the spill site, chemicals, fluids, things out in nature don't perfectly go out 5 miles around the thing, right? There are other tools or different plume analysis tools and stuff like that exist to better model how liquids or gases or whatever it might be flow away from some original point. So this is useful to a certain extent for some things, but not for everything. So just be aware of that. Now, with all of these different tools, once we start doing this geoprocessing, which I should mention, I don't think I did. It's a made-up word. It's something that ESRI came up with. But it really, geoprocessing, we're just saying anytime we're taking these feature classes and manipulating them in some way, analyzing them in some way. All right. So when we're doing this, it's very important that all of our feature classes that we're messing around with are in the same projection / coordinate system. And it's very important that they're stored in or using a projected coordinate system as opposed to a geographic coordinate system. And so that really what it boils down to is there's greater accuracy when things are stored in these projected coordinate systems, right? So we're going to make sure that our data, as we're starting to mess with them, we're going to make sure they're where they should be in space, right? That's kind of the key idea here. So they're in the proper location on the surface of the Earth if we're using that projected coordinate system. Sure, we can still have errors here and there. This is a way to eliminate as much error as possible. Also, One thing that ArcGIS can do and ArcMap can do is they have what's called on-the-fly projections, where if you bring in two different layers that have different coordinate systems, it can do some quick math, figure out where they should be in relation to one another, and draw it. So with our human eyes, we don't notice any errors at all. Right? So that's very useful. But it's not the most accurate way to do this. And so it's very important. Not only should all of our data be stored in these projected coordinate systems, but if we're going to be, comparing two different feature classes, they should also be in the same projected coordinate system. And I'll show you in the next exercise as you do how to do this, how to actually ensure that something is in the right projection. And it's this data management tools, projections and transformations, feature, and then the project tool is a way to have ArcGIS do a little extra work, do some more hardcore math to reproject that feature class. And this may be kind of vague, weird, abstract stuff, but I'll show it to you in a practical way. And it's just a way to make sure that we have as few errors as possible. Because think, when you're doing something like this geoprocessing, we're no longer making maps that are little reference things, right? Like here are all the countries in South America, or here's this or that. Those are fine, and those can be useful, but they're typically just this reference thing. You're not using it for navigation. You're not using it to make important decisions or things like that. Whereas this geoprocessing, if you screw it up, you can actually screw up, a larger project. You can make a poor financial investment. You can make a poor legal ruling. You can do all sorts of problematic things. So it's very important on our end, when we're the ones making the maps, that we do everything right. Right? That if something goes wrong, it's not our fault because we did everything properly. So that's why we want to be aware of this stuff. And then finally, I want to talk about this concept of slivers, which is another error issue. But when we overlay these different feature classes, sometimes things don't line up perfectly, and we get these little bits of error, which are called sliver polygons. What this image is trying to show is like this green line here and the green shaded area here are supposed to match up, but they don't. And so you've got this little sliver. So this happens if you do like the intersect or the union tool. You try to overlay two things. You get these little random tiny polygons that aren't really accurate results. And so you want to be aware of that. This becomes a bigger issue when you're actually digitizing data, actually making the data in the first place. But it is something to be aware of when you are doing these geoprocessing results. And we'll see some of this stuff as we move through here. It can really just screw up your statistics that you run afterwards. It can screw up measurements and things like that. And it just comes from, in some cases, sloppy work, some cases not using the right scale data. You have stuff that's too coarse for what it is you're trying to do. Like say I'm trying to do some analysis in Los Angeles County, but I'm using this global, world level data. It might not be as refined as I want it to be. So that's just something to be aware of. The quality data, the stuff that we bring in addition to the projected coordinate systems and all that, that's going to determine how successful our analysis actually is, right? And we'll get plenty of experience with that. We'll practice with that and make sure you guys are experts.